So far we have learned the technique to solve the first order differential equation. So we had variable of separable, the homogeneous, the linear, the exact, and one non-linear equation is Bernoulli. So we have finished with the first order. Now we shall start second order and higher order homogeneous and non-homogeneous differential equations. Let me consider an nth order linear non-homogeneous differential equation. So I am writing an dny over dxn plus an minus 1 dn minus 1y dxn minus 1 plus an minus 2 dn minus 2y dxn minus 2 plus a1 dy by dx plus a naught y is equal to f of x. Call it 1. This is nth order linear non-homogeneous differential equation. It is non-homogeneous because of this function. If this function is equal to 0, then the rest of the equation is homogeneous, where a's are constant. Coefficients, these are constant. This is non-homogeneous because of this. If f of x is equal to 0, the above equation takes the form an dny over dxn plus an minus 1 dn minus 1y over dxn minus 1 an minus 2 dn minus 2y over dxn minus 2 plus a1 dy by dx plus a naught y equal to 0. So this is homogeneous linear differential equation of nth order. These are powers. Powers mean these are order, nth order, n minus 1th order, n minus 2, this is first order, and there is y. So this is homogeneous linear differential equation where coefficients are constant. Now, according to the definition of homogeneous, a differential equation is said to be homogeneous if each term is either the derivative or the dependent. Each term either the derivative or the dependent. Suppose 1, 2, 3, there are a couple of terms, these are derivative and one is the dependent variable y. So this is homogeneous differential equation. Now consider a second order. We have to restrict ourselves to second order. Let a second order differential equation. Let me write a second order, which is a2 d2y by dx2 plus a1 dy by dx plus a naught y equal to 0. So this is second order linear homogeneous. There are three terms, two are derivative, one is the dependent variable itself. Call it number 2. In D operator form, d by dx is equal to capital D, a differential operator. Equation 2 can be written. A2 d square plus a1 d plus a naught y equal to 0. Look at that. Because this a naught y is outside, this is d by dx is capital D operating on y. This is d2 by dx2 is d square operating on y. So y is taken out. If y is taken out, inside is the polynomial in D equal to 0. Look at that. This is something, a polynomial in D. According to the definition, polynomial is some in variable x or whatever y, here D. So power of D must be a positive integer according to the definition of polynomial. Now if you are, just forget about it. Let me have the idea, brief idea, d2y by dx2 minus y equal to 0. If the students can find a function so that its double derivative cancelled with the function, we are getting 0. Can you do this? Can you assume y is a function, might be sin x or cos x or something. Let me have y is equal to ex. Let, I am guessing this, y is equal to ex be a function whose double derivative is ex, and once you are putting here, so you are getting 0. It means if the equation is satisfied, the given function is a solution of it. So similarly, we are defining solution of second order homogeneous linear differential equation. Let y is equal to erx. Let y is equal to erx be the solution of equation 1. Oh, sorry, equation 2. Equation 2 is there. Equation 2 is second order linear homogeneous. We are solving this, and by finding solution, how to solve a second order linear homogeneous differential equation. So let me have first derivative, which is rerx. Let me have second derivative, which is r square erx. So putting the value of y, the first derivative, the second derivative in equation 2. So equation 2 is now. So it becomes a2r square plus a1r plus a0 erx equal to 0. Look at that. Y dash contain erx, y double dash contain erx, y contain erx. I mean, they are erx. So if you are putting the derivative here, you must take erx common. Now the product of two, one is this, one is this. Product of two term is 0. Either this is equal to 0 or this is equal to 0. But exponential never 0. So we have a2r square. a2r square plus a1r plus a0 equal to 0. So this equation is called auxiliary equation. Auxiliary or characteristic equation. Yeah. Characteristics equation, or it is the auxiliary equation. So each time you are going to solve the second order homogeneous differential equation we have studied, we have having a quadratic in R. This is quadratic in R. Once you are solving a quadratic equation, there are three possibilities. Whether the roots are real distinct, whether the roots are real repeated, or they are complex conjugate. So let me discuss three cases. Case 1. If R1, R2 are roots of auxiliary equation, we are solving, let R1, R2 are roots, but the condition is real and distinct. Real and distinct are roots. So if roots are real and distinct, then solution of equation 2. Solution of equation 2 is y is equal to AE R 1x plus BE R 2x. This is the way you are writing down the solution if roots are real distinct. You are solving this auxiliary equation, you are finding roots. If roots are real distinct, you are writing the solution this way, where A, B are 2 constant because second order. If this is third order, 3 constant, fourth order, 4 constant. And we have finished with first order, so we have 1 constant. Case 2. If R1 is equal to R2 is equal to R, that is real repeated roots. Roots are real repeated. Then solution of equation 2. Equation 2 we are actually solving. Solution is A plus Bx E Rx. This is the solution if roots are real repeated. Since it is second order, so there are 2 constant. If there is a third order differential equation, roots are real repeated, 3 constant. So you can write A plus Bx plus Cx square and then parenthesis Erx. So this is going to be roots are real distinct. Case 3. If roots are of the form alpha plus minus iota beta, where alpha beta real. If the roots of a quadratic equation are of this form, a quadratic auxiliary equation you are solving, finding the roots. Roots are look like this. Then solution of equation 2 is E alpha x A cos beta x plus B sin beta x. So these are the roots by solving the quadratic equation, which is auxiliary. If real distinct, this way. If real repeated, this way. If complex conjugate, this way. You are write down the solution of a second order linear homogeneous differential equation. Example. Find the solution. Find the general solution. Because if constants are appearing, that solution is general. If you find the value of the constant, then the solution is particular. Find the general solution of the following differential equation. Number 1, y double dash minus 5y dash minus equal to 0. Number 2, y double dash minus 4y dash plus 4y equal to 0. Number 3, y double dash plus y dash plus y equal to 0. So look, 3 equations I have written and 2 terms are derivative, 1 is dependent. Nothing else. So these are homogeneous equation and always linear. Because second order is degree 1. If any other derivative or dependent variable present, their exponent must be either 1 or 0. So you can have. So it is linear first of all are linear, and then homogeneous because each term is either the derivative or the dependent. Let me solve one so that you can understand the methodology. I am solving first in D operator form. D operator form. Can I write D square minus 5D plus 6 operate on y equal to 0? Look at that. This is the D operator form. I have written the equation this. Y is taken out. From there I am writing auxiliary equation. In auxiliary equation I am writing r square minus 5r plus 6 equal to 0. This is, I have rubbed the board, and once you are having this D operator, when D is replaced by R, you are getting the auxiliary. Here you are having D and auxiliary equation d is replaced by r. It is quadratic, breaking up the middle term, r minus 2 equal to 0. Breaking up the middle term, so r is equal to 2 and 3. Roots are real distinct. Then solution, general solution will be, general solution is AE 2x plus BE 3x. It doesn't matter if you are having 3x here or 2x here because addition is commutative. So you can do anything here 3x or here 2x. So this is going to be if the roots are real distinct. Let me have the second. Second in d operator form. In d operator form. Because we are using a method d operator to solving the linear non-homogeneous or non-homogeneous with d operator. In d operator form, I am writing the second, which is d square plus 4d plus 4 operate on y equal to 0. From here I am writing auxiliary equation. It means d is replaced by r. 4r plus 4 equal to 0. If I am going to have, this is r plus 2 whole square equal to 0, complete square. So r is equal to 2 and 2 because a polynomial of degree 2, 2 roots which are real repeated. Then solution will be a plus bx, e rx, and r is 2 e. This is going to be the solution. Similarly for the third, this is the solution and 2 constant appearing because second order we are solving. There are 2 constants each time. Solution of the third, d operator form. This is d square plus d plus 1. Operator is operating on something. So something is y. Auxiliary equation. Auxiliary equation replacing d by r equal to 0. Now you cannot break the middle term. So we have applying the quadratic formula for it. So this is r is equal to minus b plus minus under root b square minus 4ac over 2a, which is minus 1 plus minus 3 divided by 2, which is minus 1 plus minus iota under root 3 by 2. So this can be written minus half plus minus iota under root 3 by 2, which is of the form alpha plus minus iota beta. Look at that. So solution will be E alpha x, alpha is half, and A cos beta x, beta is under root 3 by 2x, plus B sin beta x under root 3 by 2x. You are not going to consider minus here because that minus sign is adjusted in A and B. Because they are constant, some minus is going to be. This format is giving you this solution. So you have to write down like plus is there. Follow-ups. This is homework. So you have to have these follow-ups sometime. Find the general solution of there are 3 questions. 2y double dash minus 5y dash minus 3y equal to 0. Number 2, y double dash minus 10y dash plus 25y equal to 0. And number 3 is y double dash plus 4y dash plus 7y equal to 0. So these are the homogeneous differential equation because each term is either the derivative or the dependent and they are linear. So you have to find the solution the way I have written in a minute before. Each time you are writing a d operator form, then auxiliary, then solving the quadratic equation, Looking at the nature of the roots, write down the solution. So because there are three possibilities for the quadratic: real distinct, real repeated, complex conjugate.